Hi and welcome to Quadratic Patterns Part 1. In this section we'll go over how to create a quadratic equation from a particular pattern of numbers. So first of all, what exactly is a quadratic equation? Well, a quadratic equation is where the largest power of a variable is the power of 2. So when we've got, for example, y is equal to x squared plus x plus 1. Here we've got x squared and x. Those are our two variables. And if you notice that one has the power of 2, and in algebra we don't always put the number 1 if it's a power of 1 or if 1 goes in front of a variable. So the x is the same as x to the power of 1. And we've got x squared, which is x to the power of 2. Here 2 is larger than 1, so our highest power is 2. Okay. In a later part, I will go over the different ways that a quadratic equation can look, but today our main goal will be to try and get the quadratic equation to look something like that. So if I put over here y is equal to x squared ax plus bx plus c, where c is a constant, just like in a linear equation, and we've got a and b are also some kind of number. They can be positive, they could be negative, they can be a fraction, they can be a decimal, they can be a whole number. Okay? What number we put is what we have to work out. Now if you note here, we've got bx plus c. This is a linear part of a quadratic equation. Remember, a linear equation looks like y equals mx plus c, where c is a constant, and it is generally the y-intercept. So it is where the graph crosses through the y-axis, and the m is the gradient. Okay, well in this situation, the b will not necessarily be the gradient of a quadratic equation, but that is a linear component of this equation. So, let's look at how we can tell if we need to do x squared or not, or in this case n. Here we're using n. So first of all, let's look at this pattern. We have a sequence of 3, 8, 15, 24, 35, 48. It looks really hard to find a pattern from that. But let's try, shall we? So we've got our first kind of a difference. Let's follow the same pattern as a linear pattern. What is the first difference? We've got 8 minus 3 is 5. 15 minus 8 is 7. 24 minus 15 is 9. The next difference is 11. The next difference is 13. Okay, so we can't see any real difference there that forms a pattern. But we can see a pattern in this component over here. We've got the difference between 5 and 7 is 2. Difference between 7 and 9 is 2. Difference between 9 and 11 is 2. 11 and 13 is 2. Here, this is our second difference. So now we can tell that because it's consistent, that we're going to have n squared. But, and we're using n because over here we're using n for our number. Okay. So, how many n squareds do we have? Well, we've got a little trick. So over here we've got the second difference divide by 2. Let's divide our second difference, which is 2, by 2, shall we? So 2 divided by 2 is equal to 1, and it's positive 1. So we only need 1 n squared. Cool. But is that the whole of it? Let's find out. So we want to go t minus n squared. So 3, what's n squared here when n is equal to 1? Is 1. N squared, 1 squared is 1. Okay, and that equals 2. When t is 8, n is 2. 8 minus 2 squared is equal to 8 minus 4 is 4. Here we've got 15 minus 9, because 3 squared is 9. 3 threes is 9. Is 6. 24 minus 16 is equal to 8. 35 minus 25 is 10. Now, are you seeing another pattern here? I'll do one more. We've got 48 minus 36 is equal to 12. Here we've got a difference of 2 again. So far, if you look over here, we've got 1 n squared. Now we've got difference of 2's. So here we're finding our linear component. We've got a difference of 2. So if we went 2 times 1. So let's try this now, shall we? N squared plus 2n. When n is 1, n squared is 1. Plus 2n, that's the same as plus 2 times 1. 1 plus 2 is 3. Does that match our t? Yes. 2 squared plus 2 times 2 is 8. Does that match our t? Yes. Third time's a charm. When n is 3, n squared is 9, plus 2 times 3 is 6. So 9 plus 6 is 15. Does that match our t? Yes. So that means we need 2n in here, and that is exactly it. We don't need to have anything else. So our full general term, or our equation is t is equal to n squared plus 2n. Right, let's do an easier example, shall we? Let's go to C, which is this one here. So we've got 1, 4, 9, 16. What's our first difference? First we've got 3 as a difference. Then we've got 5 as a difference. Then we've got 7. Okay, no linear difference yet. The second difference. Let's use the same symbol for change, shall we? Our delta. Our second difference is 2. 5 to 7 is 2. Okay, so let's find out how many n squareds we are going to need. So here we use our second difference, divide by 2, which in this case is 2 divided by 2, which is exactly to 1. So let's put this in, shall we? N squared, when n is 1, 2, 3, I'm just going to put my n values in over here. When n is 1, n squared is 1. When n is 2, n squared is 4. When n is 3, n squared is 9. When n is 4, n squared is 16. Now, are these matching our t values? Yes, these are matching our t values. Already our t values are there. So our t our general term, Tn is equal to n squared. Exactly. Sound good to you? Let's move on to something slightly harder. What if just 1n squared does not fit our equation, our terms? So here we've got, let's move on to a, shall we? So here we've got, when n is 1, 2, 3, and 4, let's keep that. We've got 5, 20, 45, 80. What's our first difference? 15. Delta. From 20 to 45 we have 25. From 80 to 45 we have 35. Wow, this looks radically different. Let's keep going, shall we? Don't be scared if it looks really different from what you've seen before, okay? The key thing is just keep nutting out those steps and see if you can find a pattern. So, the first difference, we had 15, 25, 35. Normally we're used to having a difference of 5 in the first one. Let's dig into this one, shall we? Okay, so it says 15 to 25. What's the difference? It's 10. We have 25 to 35. What's this? It's 10. It's the same thing. Fantastic. We know it's going to be a something squared. Okay, let's find out how many n squareds we need. So, our little trick is second difference, divide by 2. Right? So we need this. In this case, it's going to be 10 divided by 2. 10 divided by 2 is 5. So let's try 5n squared, shall we? When n is 1, n squared is 1. N squared times 5 is 5. When n is 2, 2 times 2 is 4 times 5 is 20. Is this matching our terms? Yes, it is so far. When n is 3, 3 times 3 is 9, 9 times 5, over here, 5 times 5 is 45. Sorry, 9 times 5 is 45. Is that our third term? Yes, our third term is here. Okay, so those two match. Our pattern is continuing. Just for the sake of argument, let's try it when n is equal to 4. When n is 4, 4 times 4 is 16, 16 times 5 is 80. Is that the same as our fourth term? Yes, it is. So our general term is equal to 5n squared. Sound good? But what if it's not that easy either? Okay, let's try another one. Just going to eradicate this. So remember, the goal of this video is to be able to make an equation out of a numeric pattern, some kind of quadratic pattern. So far, we can find out how many n squareds we need. That's a really good start. Okay, so let's do D, shall we? So D is this one down here. We've got 3, 0, -5. This is looking really weird. I'm quite sure some of you are thinking this, but that's okay. We've got our steps. First, we've got to find our first difference. Delta. Our first difference is -3. We're going down. Our next difference is -5. 5. Our next difference is minus 7. Okay, this is the kind of pattern that we're used to. So our second difference is minus 2. Remember the negative numbers, so you've got to have minus. Difference between negative 5 and negative 7 is minus 2. Cool. So how many n squareds do we want? So our second difference over divide by 2 is negative 2 divided by 2. Remember, when you divide a negative by a positive number, you're going to have a negative number. There's only one negative in here. Remember, they all like buddies. There's no buddy for this negative, therefore it is sad. It is going to be negative. So we've got negative 1 is our answer. So we need something minus n squared. I can tell you now by the general look of this that is not going to be just minus n squared. A good start would be the fact that the first number is positive and it's 3, not 1. So let's go. T minus n squared. Now, if we know that it's going to be a minus, then we're going to have to say minus negative n squared, because we know it's declining. Our answer is negative 1. So we've got to have negative 1 in front of the n squared to find our difference. So when you subtract a negative number, you are essentially adding that kind of number on. So please be very careful with your negatives. I've made this mistake many times. So let's move on with this, shall we? So we've got our first term is 3. 3 minus negative 1, or plus 1 in this case, because 1 times 1 is 1. Right, this is equal to 4. We've got the next term is 0. 0 minus negative 2 times 2 is the same as minus negative 4, which is the same as plus 4. This is equal to 4. Are we seeing a pattern yet? Not sure. It's got to be at least 3 times, right? Third time's a charm. We've got negative 5 plus, because 2 negatives are a plus. 3 times 3 are 9. 3 3s are 9. Our difference is 4. Cool. Let's do the fourth one just for the sake of doing the fourth one. We've got negative 12 plus 4 times 4 is 16. Remember, we're only adding it in this case because it's a negative n squared. If it was a positive n squared, we would be subtracting it. The difference is 4 again. So there's no change in this, so we know it's going to be just plus 4. So let's try it, shall we? N minus n squared, or you could write minus 1 times n squared, plus 4. Okay, 4 minus 1 is going to be 3. 4 minus 2 times 2 is 4 is 0. 4 minus, when n is 3, minus 9. So is minus 5. See, we are matching our terms up. And this is our equation. Tn is equal to minus n squared. See, I did say I keep dropping my negatives. Hopefully no one else does. Plus 4. This is our general equation for D. Okay. Let's try one more hard one. Just one more. What one have we not done? Have we done B yet? Let's see if we've done B. So, first, second, third, fourth, fifth term. 1, 2, 3, 4. Oops, only 4 of them. Okay, so that's our N. Our term is 6, 11, 18, 27. Our first difference, our step 1. Our first difference is 5. Then 7, then 9. Oh, okay. Our second difference is 2. Oh, and 2 again. 2 divided by 2 is 1. T minus n squared. It's a positive 1, so it's going to be minus, because we want to find the difference. So we can make ourselves a linear equation here, or a linear pattern. So we've got 6 minus 1 is 5. 11 minus 4 is 7. 18 minus 9 is 9. 27 minus 16 is 11. Alright. So, our pattern is that it increases by 2 each time. See, 5, 7, 9, 11 increases by 2 each time. So we're going to have, so we know that, we'll put it down here just for now, Tn is equal to n squared plus 2n, but there's got to be something else, because 2 times 1 does not equal 5. 2 times 1 equals 2, so there's going to be a difference of 3. Let's try plus 3, shall we? Let's try it. N squared plus 2n plus 3. When n is equal to 1, 1 plus 2 plus 3 is 6. Because 1 plus 2 times 1 plus 3. Can you see that? So 1 times 1 is 1, 2 times 1 is 2, 3 is, well, 3. So that will end up being 6. When n is equal to 2, 2 squared is 2, plus 2 times 2 is, 2 squared is 4, plus 2 times 2 is 4 again, so that's 8 altogether, plus 3 is 11. 3 3 is a 9, plus 2 times 3 is plus 6, so that's 15. 15 plus 3 is 18. Okay, so when n is 4, n squared is 16, 2 times 4 is 8, 16 plus 8 is 24, 24 plus 3 is 27. Okay, and now we match our terms up in exactly the right order. So yes, this is our general equation. Okay, thanks you for listening. Bye for now.